I am Dr. Basir-Ahamed-Khan, Assistant Professor of Physics, Krishnath College. This is the lecture 2 of Module 9. Today I will discuss about Compton effect. The topics are that I will discuss the importance of Compton effect, experimental study, explanation. Explanation means the relation between the scattered photon and incident photon wavelength difference. That means we want to relate or we want to calculate the difference mathematically, the difference of wavelength of scattered photon and incident photon. In my previous lecture, in this module, I already discussed about the photoelectric effect, the importance of this photoelectric effect and the famous Einstein relation of photoelectric effect. This is the same importance of Compton effect also. What is the importance of this Compton effect? The importance is that this is the confirmation of photon model, that means the light quanta, and this experiment also explain the particle nature of light. This is the most important property or most important thing in this experiment. Now, the importance of Compton effect, this experiment confirms photon model or particle nature of light. Photon model or particle nature of light. This is most important. Now, the experimental study. Here, this is the incident photon collide an electron, target electron. This is basically rest electron, and then after collision the incident photon scattered with an angle phi, The phi is the angle between the direct incident direction and the scattered direction of photon, and after collision the scattered electron make an angle theta with the incident photon. That means phi is the angle of scattered photon with the incident direction of incident photon, and theta is the angle of scattered electron after collision, an angle between the incident photon and scattered direction of electron. This is theta. The incident photon frequency is nu, and the scattered photon frequency is nu prime. The energy of the incident photon is E equal to h nu. That means, and E scattered photon energy E equal to h nu prime, So it is obvious that the energy of the scattered photon is less than the incident photon, because some part of its energy is shared to the scattered electron. Therefore, we say that h nu prime is less than h nu. Here we can write nu prime less than nu, and if we write the corresponding wavelength in terms of wavelength, then we can write lambda prime, that means scattered photon wavelength is greater than lambda. Okay, now the incident photon momentum P equal to h nu by c, P equal to h nu by c, and the energy, since electron is rest, we assume electron is rest, that means the energy of the electron is m0 c square, where m0 is the rest mass of electron, and since electron is rest, therefore the momentum of the electron P equal to 0. And now after collision, the scattered photon energy equal to h nu, and the momentum of photon equal to h nu prime by c, and the electron energy E equal to root over of m0 square c to the power 4 plus p square c square, where m0 is the rest mass, p is the momentum of the electron, and c is the velocity of light. This relation, I get this relation from the special theory of relativity. So therefore we know the before collision the energy and momentum of incident photon and electron, and after collision the energy and momentum of scattered photon and scattered electron. Scattered photon and scattered electron. Here this is electron, scattered electron. This is the direction of scattered electron. Now here in the Compton effect, I use generally the incident photon is used for X-ray photon. X-ray photon. The energy of X-ray photon, I calculate here the energy of X-ray photon. This is E equal to hc by lambda. E equal to hc by lambda. I put the value of h in joule second and c in meter. Lambda is meter per, c is meter per second, lambda is meter. Actually the X-ray wavelength is 1 angstrom, that means 1 into 10 to the power minus 10 meter, and this is, I divide this by this quantity to change the energy from joule to electron volt. Therefore by calculating we get this is the amount of energy in electron volt 12431, that means 1.2 into 10 to the power 5 electron volt of energy of X-ray photon. This is too much compared to the visible light photon frequency energy. Here this is, I calculate the visible light, the energy of visible light in terms of electron volt. Here I put E equal to hc by lambda, and I assume lambda for our calculation 5000 angstrom, that means 5000 into 10 to the power minus 10 meter. This is 6.63 into 10 to the power minus 34 joule second. This is h, and c equal to 3 into 10 to the power 8 meter per second, and this quantity by this quantity I transform the unit of energy from joule to electron volt, and here from this calculation I get energy of visible light photon equal to 2.5 electron volt, only 2.5 electron volt. And for X-ray photon the energy is of the order of 10 to the power 5 electron volt, almost mega electron volt. That means of the order of almost mega electron volt. And here is for visible light, this is only electron volt order. That means in case of Compton effect, instead of photoelectric effect, in Compton effect the energy of X-ray photon or energy of incident photon is very greater than the visible light or say ultraviolet light. Hence the electron in Compton experiment behaves like free electron with respect to X-ray photon. This is very important thing, that the electron in Compton experiment behaves like free electron with respect to X-ray photon. Actually no electrons are free, but with respect to X-ray photon the electron in a metal, this is free with respect to X-ray photon, because the bound energy of photon is the order of something electron volt order. Because here I already calculate the X-ray photon energy much greater than visible light photon energy or ultraviolet photon energy. This is mega electron volt energy of X-ray photon, and energy of visible light ray photon is the order of electron volt. So this is important property, that electron in Compton experiment behaves like free electron with respect to X-ray photon. But in photoelectric effect electrons are bound with respect to visible or ultraviolet light photon, light ray photon. So it is very clear that in Compton effect I use X-ray photon which energy is the order of mega electron volt, and that's why the electron is almost free or like free with respect to X-ray photon. Now here we see that incident photon collide with an electron which is basically the rest electron. So it is clear that the loss of photon energy equal to gain of electron energy. Loss of photon energy after collision, the loss of photon energy means h nu minus h prime. Loss of photon energy means h nu minus h prime. This is loss of photon energy, because h nu is the energy of incident photon and h nu prime is the energy of scattered photon. Therefore h nu minus h prime equal to loss of photon energy, and it is equal to the gain of electron energy. Electron energy means the kinetic energy. So h nu minus h nu prime equal to kinetic energy of electron. This is equation 1. Now from relativity we know that for massless particle E equal to Pc. That means energy equal to momentum into C, momentum P into C. Therefore P equal to h nu by C is the momentum of photon. Now we consider the momentum conservation before collision and after collision. Now initial momentum, from the momentum conservation law, we know that initial momentum equal to final momentum. Initial momentum equal to final momentum. Initial momentum of horizontal component, that means the incident before collision, the incident photon momentum equal to h nu by c, and electron photon equal to 0. That means before collision, photon momentum plus electron momentum equal to h nu by c plus 0, 0 for electron momentum. This is equal to h nu prime by c cos phi plus p cos theta. I already said, now phi is the angle of scattered photon. The phi is the angle of scattered photon with the direction of incident photon, and theta is the angle of scattered electron, now with the direction of incident photon. That's why the horizontal component of momentum after collision becomes h nu prime by c cos phi plus p cos theta. That means pc cos theta equal to h nu minus h nu prime cos phi. This is equation 2. Again, from the perpendicular component of momentum, we get before collision the perpendicular component is 0. That means 0 equal to h nu prime by c sin phi. This is for photon momentum in perpendicular component, and minus p sin theta. This is vertical perpendicular component of electron momentum. Therefore, we get pc sin theta equal to h nu prime sin phi from this relation. That means this is equation 3. Now, from these two equation 2 and equation 3, first of all I squared this equation and then adding. That means squaring equation 2 and 3 and then adding we get, and then adding we get here equation 2, this is equation 2 and this is equation 3. pc whole square equal to sin square theta plus cos square theta equal to 1. That hence before the left hand side becomes pc whole square, and then it becomes h nu square whole square plus h nu prime whole square. That means h nu square plus h nu prime whole square minus 2 h nu into h nu prime cos phi. This is equation 4. Now from relativity we know that, we know that special theory of relativity, we know that E equal to total energy equal to kinetic energy, E equal to kinetic energy plus rest energy. Again, in terms of momentum, E equal to root over of m0 square c to the power 4 m0 square c to the power 4 plus p square c square. I already said m0 is the rest mass. Therefore, from these two relations, we say that kinetic energy plus Ke, that means kinetic energy plus m0 c square whole square equal to m0 square c to the power 4 plus p square c square. I just equate these two equation and we get kinetic energy plus m0 c square whole square equal to m0 square c to the power 4 plus p square c square. That is kinetic energy square plus 2 times kinetic energy into m0 c square plus m0 square c to the power 4 m0 square c to the power 4 equal to m0 square c to the power 4 plus p square c square or p square c square equal to p square c square equal to kinetic energy square plus 2 times kinetic energy into m0 c square Again, this is here p square c square equal to this, and here p square c square equal to this. Now again we know that from this equation number 1, the kinetic energy equal to h nu minus h nu prime. So we put this value and calculate. Since kinetic energy equal to h nu minus h nu prime, we have p square c square equal to kinetic energy square from this relation kinetic energy square plus 2 times kinetic energy m0 c square. That means kinetic energy square h nu minus h nu prime square plus 2m0 c square into kinetic energy. That means h nu minus h nu prime, or h nu square plus h nu prime square minus 2h nu into h nu prime h nu into h nu prime plus 2m0 c square h nu minus h nu prime. Now in the left hand side, this is PC whole square. Here in equation 4 we get PC whole square equal to this. PC whole square equal to this. PC whole square equal to this. That means I put equation 4 into this equation. PC square equal to this, or that is from using equation 4 using equation 4 we get PC square equal to h nu square plus h nu prime square minus 2h nu into 2h nu into h nu prime cos phi. H nu prime cos phi. This is equation 4. From this relation, PC square equal to this, equal to h nu square plus h nu prime square minus 2h nu prime 2h nu prime plus 2m0 c square h nu into h nu prime, h nu minus h nu prime. Now in both side h nu prime are cancel out. That means this h nu and this h nu prime square, this is h nu prime whole square, and the rest is that, or 2m0 c square h nu minus h nu prime 2m0 c square h nu minus h nu prime equal to 2h nu into h nu prime 1 minus cos phi. Dividing by 2h square c square we get, just I divide by 2h nu 2h square c square, dividing both side by dividing both side by 2 h square c square we get in the left hand side m0 c by h into nu by c minus nu prime by c. That means it becomes m0 c divided by h into nu by c minus nu prime by c equal to, just divide both side by 2a square c square, then m0 c by h nu by c minus nu prime by c equal to nu by c into nu prime by c into 1 minus cos phi, 1 minus cos phi, 1 minus cos phi, or sorry 1 minus cos phi, or m0c m0c by m0c by h into 1 by lambda by 1 by lambda prime, where lambda and lambda prime are the wavelength of corresponding frequency nu and nu prime. That means lambda prime is the wavelength of scattered photon and lambda is the wavelength of incident photon. Obviously lambda prime is greater than lambda, equal to 1 minus cos phi, 1 minus cos phi divided by lambda lambda prime, lambda lambda prime, and by simplification we can write lambda prime minus lambda equal to h by m0c, h by m0c into 1 minus cos phi. This is the relation of scattered photon wavelength and the incident photon wavelength. Now where this quantity is known as lambda c equal to h by m0c is called Compton wavelength. This is constant and this is called Compton wavelength. Compton wavelength. This is Compton wavelength. The value of Compton wavelength, if I put h equal to 6.63 into 10 to the power minus 34 joule second, m0 is the 9.1 into 10 to the power minus 31 kg and c is the 3 into 10 to the power 8 meter per second, then it becomes lambda c, the value of lambda c equal to 2.426 into 10 to the power minus 426 into 10 to the power minus 12 picometer. This is the value of Compton wavelength. This is the value of Compton wavelength, and this is the famous relation between the scattered wavelength and incident photon wavelength. Now if I consider phi equal to 180 degree and phi equal to 90 degree, if I consider phi equal to 180 degree and phi equal to 90 degree, 180 degree means this is the incident photon, this is incident photon, this is angle phi scattered photon, this is angle theta scattered electron, this is photon. So photon 180 degree means just opposite direction of incident photon. Then what happened? The value of cos phi equal to minus 1, that means it becomes lambda prime minus lambda is the 2 times h by m0c, and if phi equal to 90 degree then cos phi equal to 0 and lambda prime minus lambda equal to h by m0c. And if theta equal to 0, that means no effect of incident photon, and phi equal to 0 means cos phi equal to 1 and 1 minus 1 equal to 0. That means there is no difference between lambda prime and lambda. But when phi equal to 180 degree, that means if phi equal to 180 degree, phi equal to 180 degree, cos phi equal to minus 1, that means lambda prime minus lambda equal to h by m0c, h by m0c, h by m0c into 1 minus of minus 1 equal to 2 times h by m0c, h by m0c. And if phi equal to 90 degree, cos phi equal to 0, cos phi equal to 0, and then lambda prime minus lambda equal to h by m0c into 1 minus 0, that means h by m0c. So here we see that when 180 degree and 90 degree, there is no dependency of the scattered electron, the direction of scattered electron. There is no dependency on scattered electron. Suppose if we see an example, if I put an example here. Now suppose X-ray wavelength is 10 picometer. Suppose X-ray wavelength is 10 picometer. X-ray wavelength is 10 picometer. Then find the wavelength of X-ray scattered through 45 degree angle. Then find the wavelength of the X-ray scattered through angle 45 degree. Scattered wavelength when phi equal to 45 degree. And secondly, find the maximum wavelength present in the scattered X-ray. Find maximum wavelength present. Find maximum wavelength present. Maximum wavelength present. Maximum wavelength present in the scattered X-ray. In the scattered X-ray. Maximum wavelength present in scattered X-ray. Now for first one, we see that lambda prime minus lambda equal to lambda c. Lambda c means h by m0c, 1 minus cos phi. That means 1 minus cos 45 degree. Therefore, lambda prime equal to lambda plus lambda c, 1 minus cos 45 degree. Here lambda equal to 10 picometer. Therefore, it becomes 10.7 picometer. This is answer A. This is answer A. Picometer. This is answer A. This is picometer. And for second answer is the maximum wavelength present in the scattered X-ray. The maximum wavelength present in the scattered X-ray when lambda prime equal to lambda c, lambda plus lambda plus 2 lambda c. That means 10 picometer plus 4.9. That means lambda c equal to, already I know the lambda c equal to 2.426 into 10 to the minus 12 picometer. Sorry, this is not picometer, I just mistake here. This is meter. This is meter. This is not picometer, this is meter. And here this is 10 picometer and this is 4.9 picometer equal to the maximum value is 14.9 picometer. So this is the explanation of Compton effect.